Hey everybody, back with day 2 here of chapter 10 in Integrated Math 3. We are going to do problems 10.5 and 10.6 and 21 to 25 in this video. Homework is 14 to 20, which I feel like I already posted, which is good and bad, but anyway. To go back a little bit to the previous video, we were working with Gauss's formula, which is to find the sum of an arithmetic series. You take the number of terms over 2 and then times the first number in your series plus the last number in your series. Remember, he wrote them forwards and backwards, added them up, they all equaled the same thing. There was 100 of those, and he divided by 2 because he wrote it down twice. Okay, so in 10.5, it's got some rectangles, and it wants you to find the sum of these rectangles, and which is a little bit different from what we were doing with Gauss's formula, but it's actually the same. So let me just explain what's happening in this first set of rectangles. It's saying the first term, which is the first bar, is 5 high, and the second bar is 5 high, third, fourth, fifth, sixth, seventh. Okay, so notice there are 7 bars in this graph. Each of them are 5 units high. Okay, I'm only going to write this out for the first one, and then you guys will get the hang of it. So to find the sum of this, obviously it's 7 times 5, which is 35. But let's do it using Gauss's formula. So sum equals n over 2. Let's just write the formula out so we have it. T of 1 plus T of n. Okay, so let me just explain. This is how many numbers there are and how many bars there are for our problem right now, divided by 2. First term plus the last term. The first term in these graphs is going to be the height of the first bar, and the last term is going to be the height of the last bar. That way we won't have to write all of this out. So the sum in this case is 7 over 2, because there's 7 numbers here, or 7 bars in our graph. The first bar is 5 tall, and the last bar is 5 tall. 5 plus 5 is 10, times 7 is 70, divided by 2 is 35. One of the questions asked, how do you know that this is true? Well, you can tell because it's a rectangle, which is 7 by 5, and 7 times 5 is 35. Okay, B. We are going to use the same formula, but we're not going to write it all out. I can't even tell, honestly, how high these bars are, if they're quarters or thirds, or I don't know. Anyway, I can tell that the first one is 4, and then I can tell that the last one is 10, and I can tell that there are 16 bars by the x-axis. So my sum is going to be 16 over 2, 4 plus 10. Okay, so let me go over that again. 16 is how many bars there are, over 2, the height of the first bar, plus the height of the last bar. And this is 40, no it's not, it's 14 times 16 divided by 2 is 112. C. Okay, so we have 6 bars over 2. The height of the first bar is 228. The height of the last bar is 48. And that is equivalent to 828. And the last one, oh my, okay. So it looks like there are 32 bars. I can tell that because of the x coordinates. So sum equals 32 bars over 2. the height of the first bar is 14, the height of the last bar is 20, and so that's 544. Okay, great. Okay, now number 6. And you guys, I think we are only going to do A and B here. A and B will get us everything that we need to know. So how much information do you need to be able to write an arithmetic series and calculate its sum? This is a really good problem because it's going to give you different stuff than you've had before. You're not going to have the whole list or picture. You're going to have to use algebra to kind of figure it out. So this problem is kind of key for strategies. Okay, so A. You know that the first term is 18. Okay, so I'm going to write T of 1 equals 18. You know the last term is 72. Okay, notice they didn't tell you what that was, so that's a variable. The last term is 72. And that's okay because look, we have to plug in for T of n. And the common difference is 4.5. Okay, the common difference is another word for the growth. Okay, what's the series? What is the sum? Okay, so we'll start by writing the series, and the series starts with 18 and then goes up by 4.5s each time, so 22.5 plus, and then you're going to have some things in here, and then it's going to end at 72. I hope that that makes sense to everybody. Okay, and we need to find the sum for this, so let's just see what we need to plug in. Oh no. Oh, this looks like a whiteout moment, but I don't know where my whiteout is. So it's going to become n over 2 t of 1 plus t of n. Okay, do we have t of 1? Yes. Do we have t of n? Yes. Do we know how many terms away 72 is? Well, if we sat with our calculator for a really long time, we could figure it out. I don't really want to do that though because I'm lazy. I know that I'm going to have something over 2, first number is 18, last number is 72. What I want to find out is how many numbers out is 72. Okay, the way I'm going to do that is by using the explicit equation and solving for n. So the explicit equation, just to remind you, is growth n plus 0th term. Okay, so what I have to do is kind of go backwards one from 18. 18 minus 4.5 is 13.5. I've got some advanced students out there who might want to write 4.5 parentheses n minus 1 plus 18. That is great also. Okay, so notice I have my explicit equation, growth n plus 0th term, and I know t of n, that's 72, and what I can do is plug that in and solve for n. 72 equals 4.5 n plus 13.5 minus 13.5 from both sides, and I have 58.5 equals 4.5 n, divide, and I have 13 equals n. Okay, so that means that 72 is the 13th number. And if I were to make a graph of this, there would be 13 bars. So 13 goes there. And the sum 585. Okay, there will be some of you who prefer to do this the long way. So you are allowed to, if you want, I do not care, to take this and just write the series all the way up to 72 and then add it up on your calculator. If that's something that you're interested in doing, please, by all means, go ahead. I'm not going to punish you for that or mark you down or anything. That totally works. I just wouldn't do it myself because I'm lazy, but it's good. You know, it's also a good approach. Okay. B. You know that there are 6 terms. Okay. 6 terms. N equals 6. Great. And the last and smallest term is 21. Okay, so actually that's going to be T of 6, is it not? It's the last term, and it's the smallest term, and the sum is 336. What is the series? Okay, sum equals n over 2 t of 1 plus t of n. Okay, sum equals 6 over 2 t of 1. I don't know that, so I'm going to put x. That's the one thing I don't have in this case. Oh, I should have put a number there. That's okay. T of n, which is 6. Notice this is 6, so this becomes t of 6, is 21. It also told us it was the last and smallest term, so the last term always goes there. T of 6, because that is 6. Okay, and then the sum was 336. Okay, 336 equals 6 over 2 x plus 21. Okay, so 3 over, I just said the answer. 336 equals 3x plus 21. And 336 equals 3x plus 63. And minus 63. 273 equals 3x. Divide by 3. 91 equals x. Okay, what is that? That's t of 1, which is the first number. Okay, so I know my first number is 91. These should be pluses. And I should have 6 numbers, and my last number is 21. Okay, but I don't know how far apart each one of them are. So how could I find out how far apart they are? Well, let's use the explicit equation. Does that not have the common difference or the growth in it? Okay, now in this case, I don't know the 0th term. So I'm going to have to use the equation written in terms of the first term. So t of n equals growth times n minus 1 plus first term. Okay, so t of n in this case is our last one. 21 equals growth is what we're trying to find. 6 terms, and the first one is 91. Okay. Okay, what does this mean? This means the growth is negative 14. So that means these are going down by 14s each time. Okay, so that means that this is down, so 77 plus, and then down 14, till you get to 21. Okay, so that's the conclusion of this part. I am going to start a new video for the next part so they don't get too long. See you guys in a minute.